Hello and welcome to another episode of TDD as if you meant it. This is the second episode, and as I've done in the first one, I'll start a Pomodoro, and in 25 minutes, whatever we do, we'll stop recording. Last time we made this analysis. We thought about the red-green refactor process. We added the think part, meaning the analysis we need to do sometimes. We discussed about these guidelines. I'll number them as well, and we made behavior slicing. We looked at the outputs, and then we continued to understand which are the possible inputs with that. After that, we continued with the part with x1 and wrote a test. Continued with the red-green refactor cycle. We made the test green, and with the simplest code possible, we made it pass. Then with refactoring, we added some comments here and just to structure it so that you understand it better. And now we are looking to triangulate. It's about this guideline. The purpose is to write more tests around this concept when x1, and we would need to write the next test that goes around that idea. So let's see what's the next possible test now. I will start again with assert equals. I have an expected, I have an actual. Sorry, the expected, it's clearly x1. And now I'll do a bit of more structured coding. This is the arrange already. This is the assert. So what I need to fill is the act, and only after that the production code, when I'll start being I will become green. So the act is basically the fact that we have an actual, but now this is just an empty string. So if I would run, I would save this, run the tests. This is red because it says x1, but actual nothing. Okay, so now again I need to think in which context could x win. And here I have more options. I could go a bit lower to the silly case where the board is 0 by 0, and well, it doesn't make any sense, of course, but as I said in the first episode, we want to simplify, and we want to start from something that's very simple to something that's more complex. And then we could use another case when we have a 1 by 2 board or a 2 by 1 board, and we need to understand what happens then. It's clearly a case where I don't have something set up in the game rules. So let's see how this works and how it looks first. So what I'd like to do, let's say x plays. So I have a board 2 by 2. If x plays in the top left corner, then I have 0 plays here, top right corner, and if x plays here, then x will win. So let's try this for 2 by 2 board. X wins on a column. So in the arrange part, I also need to add this string board 2x2. And as I've done last time, I would extract this to game result. This is the production code, so that's why I want to move it here. And here I want to write the production code. So if the board is 2x2, but it's not really 2x2 because it's 2x2 but it wins with a column. So the correct production code is 2x2 with X on left column. So this is what I mean here. It's 2x2 with X on left column. So this is what I would need to give it as an input with the board. So in this case, as shown here, probably X will win. So let's see if this works out. Great, so now I'm on green. Again, can I refactor anything? I've done some adjustments to the code. I didn't do anything now, so I just go with commit, edit second test with board 2x2 and X wins on left column. Last time we discussed about this guideline, introduce only one notion at a time. Here I introduced the notion of winning. Here I'm introducing the notion of column. I'm still triangulating on the win condition, so x1, but I sometimes need to introduce some other concepts in order to be able to triangulate on that, and I don't want to introduce too many notions, preferably only one new notion at a time, or even none. So let me commit again, edit comments with the notions introduced. Good. Now let me add another test. For 2x2 board, X wins on right column. Again, I have range, production code, act, assert. In this case, again, I'm starting with the assert equals. I have an expected, I have an actual. What is the expected? Well, the expected is, as always, x1. I'll move this to the arrange. The actual is nothing yet. And in the arrange, I also have the far thing that the board is 2 by 2 with X on right column. So if I'd make a comment, it would be like that. I don't have anything here. X plate on the right top. Then let's say 0 plate here. And then X plate here. And then X1. So this is what I mean by this. I will do again this extraction. So this is game result. Now I am now on red, hopefully. Yes, so my new test says X1 actual nothing. Here it's very interesting that I'm not introducing any no notion, no new notion. Okay, I have this right and left column. They aren't really domain concepts, so it's just a thing that it's a correct characteristic of the column concept. Okay, so now how would I make this fast? Well, again, if I say board is 2 by 2 with X on right column, of course X1, else nobody won. Let's see. So now I have a green. Let's do a bit of reshaping, refactoring. Now I see that this test says for 2 by 2 board X wins on column, for 2 by 2 board X wins on right column. Here it's implicit that it's on left column, so I'd like to change that in order to have a very explicit name of the test. And I think that's it for now for the first part of refactoring. I run again the tests and then I will commit, and then we'll look at duplication. Edit third test with X wins on 2 by 2 board on left column. Okay. I'm starting to see this thing X1. It's here, it's here, it's here. So I'm triangulating on this. This was what I wanted. So now let's start extracting. It asks me, look, I have this thing more times. I have two occurrences. It's here and it's here. For now, I'll just replace this one. What are you doing? Okay, so this is game message x1. I have it here as well, so I'll extract a variable here. Game message x1. And I have it here as well. Game message x2. x1. Now I start seeing that this thing happens all over again. So I want to extract a method, get game message x1. It says, hey, I found this more times. Do you want to extract it? Yes. I don't want to replace it here. Here, yes. Here, no. Yes, no. Yeah, so that's good. So I have this thing here. I have my first method. I extracted this one. Let's run the test, see if everything works well. Good. Let's do a commit. Extracted method. What do you call it? Get game message x1. Okay, now I will use my favorite refactoring, which is called inline. So if you look on the refactor this part, you'll find it here. So it's inline, and what it does is, in fact, it gets rid of this unnecessary variable, and this happens often when you do extractions. As you see, my code, my test code is shrinking, so this is good. I expanded it a bit and then it's shrinking. This shows that my production code starts being more refined, and this is what I'm searching for. Why I didn't extract it from here yet? Well, I want to separate a bit the expected range from the production code. Now I can do this and everything could work well. It's not always a good idea to extract from everything at the time, because you can get false positives. When the IDE helps you, yeah, that's a thing I would do as well, but I just wanted to show you that sometimes taking small steps is necessary. Now again, this expected variable is not necessary anymore, so I could inline this. If I have good methods that have good name, I understand what's expected here. So as I told you, the test method is getting smaller and smaller. It's shrinking, and this is what I'm looking for. So let's do another commit using method get game message x1 in all the tests. Now let's see what other things I could refactor. Here I use a board, and this is a specific board. So let me extract this again to variable. I want to start extracting my primitives, and I want to extract them to variables. This is a generalization step, and it's always present like that in any type of evolutionary design. When you want to generalize something, you generalize it from a variable, from a primitive to something like variable, and you make it more generic by extracting a method. A class is more generic, and so on. So I want step by step to get rid of these things. Another thing I can extract is nobody one, because this exists everywhere. And now let's see if my ID helps me. Maybe it will spot this everywhere, in all the 3 tests. My message would be something like, so like it was here, get game message x1, but I would extract something, get game message nobody 1. Says, hey, I have the others. Do you want to extract it? Yes. Yes, yes. So if you do this, you do less inlines, and that's fine, you're faster. So if you have an ID that helps you do this, that's great. I like putting these, so typically the ID puts them on the bottom. I like putting them on the top because I want to start writing new tests on the bottom at one moment. So yeah, after these comments that I typically don't write, but now it's just to show you the guidelines and so on. So I'd like putting them on the top, and one by one I will extract these 2 classes. So now, as you can see, things are getting more and more structured, and I get rid of these primitives. Okay, I cannot yet extract this because it just appears one time here, and I can do something else. I can do something like board 1 by 1. Okay, and I don't know, maybe it's in the production code. Probably it's in the production code, but I'm just using explain variable refactoring to make sure that this is more generic, and I can do a bit the same here. So if I do this, let's see, would this work? Yes. And I want to show you how duplication can happen in strings when you use this, let's say, technique of starting with primitives and explaining these domain concepts with primitives. This is a board, and it's a 2 by 2 board. I would in fact rename it like this one, board 1 by 1, board 2 by 2, because then if you have the noun at the beginning, you'd be able to see that that's important. That's the noun. The board is the domain concept, and then 1 by 1 is just the detail. So let me rephrase this. It's board 2 by 2. And here is the same. Board 2 by 2. My purpose is to make these things identical in all the tests, so that I can extract this function. Now I have extracted this into variables and to some methods from the first test. Here I still have some texts here, and now it's the moment to understand which other concepts I have. With X on right column, that it shows me a structure, a pattern of the board. So what I can do is look that here I have left, right, and then I have the concept of column. So clearly I could separate these, but I don't have it yet 3 times in 3 tests. If I'd like to continue triangulating on column, I would need to write another test as well. But I can extract this to a variable. And as you can see, my code is getting bigger. I have more things.
Stop coding now. Next episode will follow.
And my lovely assistant tells me that Pomodoro
Stop
is
coding
finished.
now. Next episode will follow.
I will just run the...
Stop coding now. Next episode will...
I will just run this. I'll go back just because it's red. I've done a mistake. And maybe you will understand which is a mistake, but I don't want to take the time now to reconfigure everything. So I'll just go back so that you will you'll not take more time on seeing this in this episode, but clearly in the next episode you'll see what was wrong. So thank you for watching. I will do a commit, factored, so extracted variables from the tests. Thank you for watching. I'll see you next time, and you'll see how we evolve this code to a nice tic-tac-toe game. Until next time, thank you and have fun coding.